Hi everyone, welcome to thlympic. Today we are going to solve 4 new questions from Math Challenge Olympiad. Let's start. So this is our first question from category 1 and grade level 4-5. So the question says, sum of 5 consecutive numbers is 155. So what is the largest one? First of all, let's see what's consecutive. Consecutive means numbers that follow each other. For example, if first number is 10, then the others are 11, 12, 13. So it goes in that way. So since there are 5 of them, if we call the first one x, the next one will be one more, x plus 1. After that, x plus 2, x plus 3, x plus 4. So we have 1, 2, 3, 4, 5 numbers, and they are consecutive, means they follow each other. So the question says their total is 155. Let's add them. X. So I add first the x parts. 1, 2, 3, 4, 5x plus 1 plus 2, 3 plus 3, 6 plus 4, 10. So they all together makes 5x plus 10 equals 155. So if we take 10 to other side, 5x equals 155 minus 10. Or we subtract 10 from both sides. So 5x equals 145. To get 1x, we divide both sides by 5. So x equals 145 over 5, which is 29. But the question is not finished. Be careful. This x is the smallest one, but the question asks the largest, which is x plus 4. So to get x plus 4, x is 29, so 29 plus 4, which is 33. So the answer D. So our second question is about equations with 3 unknowns and there are fractions. But for this kind of questions, there should be an easy way because 2 equations and it seems like 2 equations, but actually there are 1, 2, 3 equations here, and with this there are 4. But it is not clear, like it seems like here 1 equation, here another equation, 2 equations, but we have 1, 2, 3 unknowns, or 1, 2, 3, another 3 unknowns. So it looks hard, but let's try to understand what's going on. So they ask x, y, z, their total. So these equations, we can separate each of them and make one equation. So let me take a pen. So we can separate these equations and each of them is for one of these. So ax is 6, by is 6, cz is 6. So for each of them, we can write separate equations. From here, let's first isolate what is x, what is y, what is z. So x equals 6 over a, y equals 6 over b, and z equals 6 over c. So if you don't know how to do this part, so divide both sides by c. For example, divide by c, divide by c. So these c's will cancel, z will be 6 over c. Right now we get x, y, z. So let's add them. So x plus y plus z equals 6 over a, 6 over b, and 6 over c. So here we got something very close to this one, but here they are 1 over, but here's 6 over. But since all the x's are 6's are common, so we can factor out 6, then we can rewrite this expression in this form. So now you see that, okay, now we see that the inside bracket is exactly what is given here, which is 3. So 6 times 3 equals 18. So the answer A. So our third question is from category 3, and the question asks, which one is the greatest? So it seems like this 10 is a big number, 5 is also a bigger number comparing 2. So probably these may be the bigger number, but actually, let's see, are they big or not? So for this kind of questions, one thing first, you can change these numbers into indices. So for this, there is a formula. Let me shortly write if you do not know what is the formula. So in square root, for example, a power b, and degree of the root is c. So to change this into the index form, we write a power b divided by c. So here in our question, the power of 10 is 1, power of 5 is 1, power of 2 is 1. And square root doesn't have degree. I mean, it has, but it is not written. Here, the degree is 2. So using this idea, let's change this into the index form or indices form. So this will be 10 to the power 1 over 10, 5 to the power 1 over 5, 2 to the power 1 over 2. So we have these numbers, but still it is not easy to compare them. So now this one, remember, we can extend the fractions, equivalent fractions. So let's write that rule also quickly. For example, let's say if you have a over b, and if you multiply both sides by c, so still you have same fraction, ac over bc. So this is another rule to expand the fraction. This is also a rule. So using this idea, we multiply both sides by 2, and we get 2 over 10. So similar to 1 over 10. After that, we separate 1 over 10 as an extra power and 2 inside. So if you check the rules for indices, we can multiply these 2 powers, so we will get the same. It means this one we can rewrite in this form. Now, look, we have power 1 over 10, power 1 over 10, so we can compare these two. And 5 squared is 25, so this number is 25 power 1 over 10. And the last one is 2 power 1 over 2, but I want to make degree as 10. So multiply both sides by 5, according to this rule, so we get 5 over 10, and we separate power 1 over 10 using this rule. Now this is inside is 2 power 5. So if we change it to the integer, it will be 32 multiplied to 5 times by itself. Now we have all the numbers with same power: 10 power 1 over 10, 25 power 1 over 10, and 32 power 1 over 10. So in these cases, if the bottom is bigger, so the number is bigger because the powers are same. So this is the biggest one, then this one, then this one. So which one is the biggest? This one. So here, 2 power 1 over 2. Answer is C. And our final question. So here the question gives tangent 18 as x and asks sine 36 in terms of x. So to solve this question, I used double angle formulas at first. I wanted to use, but it seems like it is getting complicated. So I didn't continue that one, and I used this method. First, I show this tangent 18 on a right triangle. So this is 90 degree. Tangent means opposite divided by adjacent. So x over 1, which is x. So this is what this equation represents, these two. But I draw another triangle, like same triangle, but I make it a little bigger, and I add this extra line. So these two are equal. So we have an isosceles triangle here, and 18 plus 18, 36. So this is 1, the whole length is 1. If I call this k, the remaining part is 1 minus k, because the whole is 1. And these two are equal, so k, and x. Now, in this triangle, we can write the Pythagoras theorem. So x squared plus 1 minus k squared equals k squared. So do you see? So if I know what is k or what is x, if I can write one of them in terms of other, so we can easily find sine 36. Sine 36 is opposite divided by hypotenuse, so x over k. Here, sine 36 is x over k. Now let's expand this equation and try to get k in terms of x. So we extend this. If you don't know how to, you can check. We multiply 1 minus k by itself 2 times. So the expansion is 1 minus 2k plus k squared plus x squared equals k squared. Now let's this k squared, they cancel out each other. So let's take it and for 1 minute. So these two and these two, they simplify. What is left is x squared equals, let's take these two to the other side, 2k minus 1. Okay, let's take 1 here, x squared plus 1, 2k, k equals this one. So now we get k in terms of x. What we need to do is just check what is this ratio. So x divided by k. So this is x and this is k. See, we did the substitution here. So, and if this is a division by fractions, so when we divide by fractions, we flip this and multiply. So x times 2 over x squared plus 1. So if we do multiplication, the answer will come 2x over x squared plus 1, which is answer D. No, not D, C. Yes, this is the answer. So thank you very much. That's all for today. So see you in next video. Bye.